Specific latent heat of fusion. The specific latent heat of fusion of a substance is the quantity of heat required to convert unit mass from solid to liquid without change in temperature. Latent heat Q equals to mL. Therefore, L is equals to Q over M joule kilogram per kilogram. The unit of specific heat of fusion is joule per kilogram. Calculation on specific latent heat of fusion. Heat given by calorimeter and water on cooling is equals to heat used in melting ice at constant temperature plus heat used in warming the melting ice from 0 degrees to T2. In bracket M1 CW plus C close bracket open bracket T1 minus T2 close bracket is equals to ml plus mcw in bracket T2 minus 0. L fusion is equals to m1 in bracket C1 CW plus C open bracket T1 minus T2 close bracket minus mcw T2 all over M, where L is specific latent heat of fusion, C equal to the thermal capacity of calorimeter, T1 is equal to the initial temperature of water, T2 is equal to the final temperature of the mixture, M1 is equal to the mass of water, CW equal to specific heat capacity of water, and N equals to the mass of ice. Example 6. A calorimeter contains 600 grams of water and 100 grams of at 0 degrees centigrade. A piece of hot metal of mass 1 kilogram is gently added to the mixture in the calorimeter, and this causes all the ice to melt. Calculate the initial temperature of the metal, taking the specific heat capacity of water equals to 4.2 times 10 raised to power 2 joule per kilogram per Celsius. Specific latent heat of fusion of ice equal to 3.36 times 10 raised to power 5 joule per kilogram per Celsius. Solution. Let T degrees centigrade be the initial temperature of the metal. Heat required to melt the ice at constant temperature is equals to ml. This equals to 0.1 times 3.36 times 10 raised to power 5 joule. Heat lost by the metal in cooling from T degrees Celsius to 0 degrees centigrade. MC in bracket theta 2 minus theta 1 is equals to 1 times 4.2 times 10 raised to power 2 times in bracket T minus 0 is equals to 4.2 times 10 raised to power 2T. Heat lost by metal equals to heat gained by ice. 4.2 times 10 raised to power 2T is equals to 0.1 times 3.36 times 10 raised to power 5. Making T the subject of the formula, we now have T equals to 0.1 times 3.36 times 10 raised to power 5 all over 4.2 times 10 raised to power 2 is equals to 80 degrees. Therefore, the initial temperature of the metal is equals to 80 degrees Celsius. Example 7. 0.5 kilogram of water at 10 degrees centigrade is completely converted to ice 0.0 degree centigrade by extracting 188,000 joule of heat from it. If the specific heat capacity of water is 4,200 joule per kilogram per Celsius, calculate the specific heat of fusion. Solution. Heat lost by water from 10 degrees centigrade to 0 degrees centigrade is equals to MWCW in bracket theta 2 minus theta 1, where is equals to 0.5 times 4,200 times in bracket 10 minus 0 is equals to 0.5 times 4,200 times 10 is equals to 21,000 joules. Heat loss at constant temperature of melting is equals to ml, which is equals to 0.5 L. Total heat extracted is equals to 188,000 is equals to 21,000 plus 0.5 L. Heat gained by I is equals to heat lost by water. 21,000 plus 0.5 L is equals to 188,000. 0.5 L is equals to 188,000 minus 21,000, which gives us 16,700. 1 L, making L the subject of the formula, you have that 16,700 over 0.5, which will give us 334,000 joule per kilogram. Therefore, the specific latent heat of fusion of ice is equals to 334,000 joule per kilogram. Example 8. Calculate the amount of heat required to convert 2 kg of ice at minus 2 degrees Celsius to water at 0 degrees Celsius. Specific heat capacity of ice is equal to 2090 joule per kilogram per Celsius. Specific heat of fusion of ice is equal to 333 times 10 times 1000 joule per kilogram. Solution. Heat gained by ice from minus 20 to 0 degrees is equals to mct. Is equals to 2 times 2090 times in bracket 0 minus 2, which is equals to 2 times 2090 times 2, which is equals to 8,360 joules. Heat gained by melting ice at constant temperature is equals to ml, which is equals to 2 times 333 times 1000, which is equals to 606,666,000 joules. Heat required to convert ice to water is equals to 8,360 plus 666,000, which will give us 6,743,360 joules. Specific latent heat of vaporization. The specific latent heat of vaporization of a substance is the quantity of heat required to change unit mass of the substance from liquid to vapor without change in temperature. The SI unit of specific latent heat of vaporization, joule per kilogram. Calculation of specific latent heat of vaporization. Heat given by steam on condensing at constant temperature ml plus heat given by condensed water on cooling from 100 degrees centigrade to T2 mCW in bracket 100 minus T2 is equals to heat taken by calorimeter and water, that is M1CW plus C in bracket T2 minus T1, making the latent heat of vaporization the subject of the formula. L vaporization is equals to in bracket M1CW plus C in bracket times in bracket T2 minus T1 minus in bracket mCW plus C times in bracket 100 minus T2 all over M, where M1 is the mass of water, CW is equal to the specific heat capacity of water, C is equal to the thermal capacity of calorimeter, T1 is equal to the initial temperature, T2 is the final temperature, and M is the mass of condensed steam.